Hello, everyone. That was very interesting keynote panel. A lot of the themes that we talked about in my welcome was getting reflected. So it was interesting to get those views from across the cross section of the industry, from a BHP to Mitsubishi to BASF. Now this is the showstopper event for us, which is all about the release of BrainSap. So this year we're releasing Fluorite 20, and this has gone. A lot of hard work has gone in, and actually some of our customers are already using some of the Fluorite apps, which you will hear about as we go through the day and the different sessions. We looked at the three core challenges that the industry threw at us. The first one was about how do you track material from mine to plant. We've tried to address that by connecting spatial and time series data. And you will see that we now have in BrainSap is one platform which can handle both of these different data sets and able to run models on top of that and deliver value for the clients through the individual applications. The other big challenge that was thrown to us was, how do you make AI models more explainable? How can we know what is happening? How can you make sure that we can provide the weightage, right targets, right ways to run that model so that it is more configurable? So it is more way we understand what's going on. So we have actually built a lot of hooks for delivering that. And actually that helps in organizational learning, because as we heard today, it's a transformation, it's a change. And for change, the first thing it starts with is education. And for education, you need to give clarity on the data, clarity on what the model's outputs are. And finally, one of the biggest challenges that we have encountered over the last 5 years has been the quality of data. And we all are aware of the mining industry. We're all aware of some of the incredible challenges that you face and the issues that we have with sensors going down, sensors going out of calibration, a lot of these data gaps that happen. And these data gaps, handling these data gaps in a real-time AI model is quite tricky. It's very, very difficult to do that. You don't find those real-world conditions when you are, for example, applying AI models on a Google's AdWord platform or Facebook's social graph. So it is quite a unique challenge that the industry has, where we need to build platforms, technology that can handle those different types of data gaps. And be able to solve those problems. So the idea is, how can you address the data quality, but also autonomously resolve them by different techniques that you can use, from various types of data like GPS data to time series data on the different plant PLCs. And we have been working really hard on that. And I think that is one of the other core modules that we're really excited about to talk about that. So without further ado, I would like to bring up Mark de Geus, our product director, to come over and share with the industry what Fluorite 20 is going to deliver back to the industry. Mark, come on over.
Thanks a million, Sam. I'm Mark de Geus. I'm the product director here at IntelliSense.io. I'm really excited to welcome you all to this BrainSap Fluorite 20 product launch. I'd like to take 2 minutes to thank the team who's made all of this, what you're about to see, possible. And so let's get started. So the first question that probably a lot of you are asking is, what is BrainSap? So BrainSap is a real-time decision-making platform for the mining industry, powered by artificial intelligence and industrial Internet of Things technology. On top of that, IntelliSense optimization applications are out-of-the-box process optimization solutions for each process within the mine to market value chain. Now that we have the two products defined, I'd like to also introduce Fluorite to everybody. So the concept of Fluorite is that every 6 months, both of these product suites at IntelliSense are updated and upgraded. As we're a mining focused and slightly nerdy company, we have decided to name these after minerals. And so I already look forward to welcome you all to our Graphite 21 release in 6 months' time. So what have we looked at in Fluorite 20? I've highlighted the three main topics here that Sam has also brought up throughout his vision. And I just wanted to highlight quickly that we are here to help. We are here to solve challenges. And I think personally, we took on one of the biggest challenges in mining, which is to do with this link between spatial data and time series data, normally related to geology and mining, and then processing and refinement of the material. Often this is linked to data being siloed from geologists all the way through to those working in the plant. However, as our applications mature in each area of the mine, we are able to make this link finally. And I think that allows this transparency we've been talking about in AI, and so that we can all speak within mining the same language. I'm personally a metallurgist by training, and it's great to be able to talk to a geologist about how exactly material affects my process. To do this, I think there's a number of hurdles which I've highlighted here. To name one, data comes to mind. I don't think mining has a problem collecting data. However, I do think due to its nature, the data is often of varying quality. And so what IntelliSense has tried to do is to make sure that we overcome that by filtering, and even in some cases, replacing that data to ensure the recommendations that you get from our IntelliSense applications are both robust and accurate, and therefore are trusted by those who use it. The first topic that I'm going to talk about today is that idea of linking spatial and time series data. The thing that I will highlight is the material movement. And we'll start upstream and we'll make our way downstream throughout this presentation. This for me is a great opening slide. I personally signed up to a career in mining as it seemed exciting, challenging, and for most people from Ireland, it's slightly different. And I think the reality that I came to was more representative of this photo than any other. All of those preconceptions potentially went out the door. So what happened in this case? What caused some of this issue that I'm looking at in this photo? It's caused by the dynamic and unpredictable nature of mining. So this reality, however, I saw and I thought must be preventable. And IntelliSense are here to help with that. Surely we could preempt the physical and geometallurgical properties of this material and make better decisions. How can we make mining more like a factory? And really what I'm going to show you today is how IntelliSense can do that. How we won't be guessing anymore. We won't be just reacting very, very quickly to material, so that for those next generation of miners, hopefully a career in mining will be challenging and exciting and not just exhausting and frustrating and reactive. And so I think let's get going. Let's jump into our product and let's get started with demonstrating this first step, which is looking at the material and how we can take spatial data and move it along. So I'm going to open the Brains app now. Okay, so let's log into Brains app. Brains app has a secure login. It's available in multiple languages and it's available on any browser. So I've jumped straight into one of our solution panels, which are a combination of all of our widgets, and they're here to tell a story to you guys. So the IntelliSense products, as I've shown here in this opening widget, the IntelliSense products are split across multiple product groups representing the mining value chain. For this solution panel, I'm going to focus on the digital mine. So each one of our applications represents a process. And for the start of this solution panel, I'm going to talk about the Stockpile application. And so the Stockpile application represents stockpile management, which for years within the mining industry has often been either a mystery or of less value to mines, or essentially discounted as just as a side to our main feed to the plant. And for this reason has been modeled and approached in the same way without real focus. However, I think if you want to understand the value inside a stockpile, the industry standard used to date has been the weighted average model, or as we call it, the WAM. The outputs of that, however, are not good enough if you're trying to find value and digitalize your mine. The outputs are shown here. They're often just a homogeneous set of properties given to an entire set of resources. However, the IntelliSense modeling approach using grids accurately models in real time the stockpiling process. This obviously has its challenges to do with data quality, filling even of data where required. And the outputs you can see here are this almost rainbow set of blocks, which are made up of multiple different properties. So how do we get here? As I said, there's a number of challenges to get here, including data, but realistically what we are doing is simulating and modeling truck dumps, you can see here, as well as dosing, which is often an ad hoc solution to the top of a stockpile, which can cause inaccuracies. The result of this is now that I am able to understand not only the total mass inside my stockpile, but also every single one of my grades and properties, including densities, all in real time and to a higher degree of accuracy than I could have ever imagined using the weighted average model. You can see here the breakdown of the mineral grade. This is not only applicable to value-based stockpiles. A lot of people, when they see mines from space and when we see pictures of mine, we see these gigantic man-made mountains and structures. And a lot of these are waste stockpiles. The same approach can be taken to these waste stockpiles. As you can see here, we can take the total mass and we can take the grade of these different properties. An interesting approach to this is not only with the valuable stockpiles, but also the waste stockpiles, is that we can then calculate the total value within a stockpile in terms of actual dollar amounts, which is an interesting way of seeing waste stockpiles in a new light. Once a stockpile has been there for some time, we obviously need to reclaim it. So the action of reclaiming is then modeled as well within the stockpiling app. So you can see here the reclaim of mass. And really what is interesting is when we start to look at the differences between WAM and grids. And so you can see as you're taking material from the stockpile, the weighted average model is this homogeneous set grade. However, the grids, as you can see the different blocks of different properties are being extracted, you can see a variability which is incredibly valuable downstream of your stockpiling process. Now that this has been taken out of our stockpile, we now need to transport it to a destination. This is where I'm going to introduce you all to the material model. The material model is our way of tracking material. It's both physical and geometallurgical properties that we can track over time. In this case, we've taken that material and we've dumped it into a crusher. So one portion of the reclaimed mass that I have here is sent to a crusher, or the start of our processing plant. What's really interesting here is that we can now look at a planned versus an actual in real time, which is fantastic for those in reconciliation, as well as looking at the grade of each dump, and the difference between grids and WAM as well is obvious. The other thing that we can do is see how this works with a blending plan, so we can really advance our planning. What I've shown you here is very operational, really real-time insights. However, it's the end of the month, and as a geologist, or even as a shift, I need to now report this information. So quite easily, any of these solution panels or dashboards can be turned into reports. And so I'm using here now a wider variety of some of our widgets to show new information that maybe is required for reporting. So these can now be used in a number of different ways. So I can download this, save it to my files as a PDF, for example, opening it here. If that's not required, the idea of interoperability or using that data elsewhere can also come into play. For that purpose, I can also download it as a CSV. However, I don't want to do this ad hoc. I'd like to report on a regular basis. And so quite easily, I can come here and set up a new subscription in which I select the dashboard of my stockpile report. I want it as a PDF every day at midday for the past 12 hours, and I'll have that delivered to myself by email. That will now come through every day, therefore saving me huge amounts of time. In terms of interoperability, the last step is now using the stockpile for planning. We now have this 3D visual, so how can I use that elsewhere? So the IntelliSense models are 100% interoperable with other mining softwares, whether it be a geological software or a mine planning software. If I take one of these and I go into the asset itself, so this is my asset hierarchy and all the different assets within my mine, I can find my stockpile here, my ROM-pad stockpile, find more information on it, and look at the files that have been generated each day on this asset. I can click on this, download it, and within a few seconds, I will have an accurate picture of my block model. I can then use this in other softwares. I'll just bring up a really commonly used visualization software in geology, which is Leapfrog. And you can see here the block model in 3 dimensions of the 2 stockpiles. So this really highlights as well, if I switch between WAM and my original grids model, you can see the differences here in every single one of my properties that I want to look at. Therefore, allowing me to have much better planning and much better accuracy in terms of return on investment. So I've talked about the material upstream of a processing plant. Now let's get into the processing plant and how we can use that new data to enhance and ensure that we get the most recovery out of our metal. To do that, I think we address the point of data quality and autonomy here. It's always great to show some real life examples of the product in use on different mine sites. You can see here 3 different operators using our Brains app product. I personally like the phrase in terms of data, that data is a new gold. I then question when we meet some of our gold miners, does that mean that data is just gold or is new gold? I don't understand, but let's talk about data. So people talk about getting more data, right? Often it can be difficult to get more data. These are inhospitable places, lack of Wi-Fi, things like that. So how do we actually get more data? That's one question. And then if we get more data, how can we use it better? There's another point that I think is another source of new data, which can be engineers currently use a lot of simulators. And for me, they're very complicated. And I don't know how many people are trained in using simulators and things like that, but often at times they're making a very complicated process into an overly complicated software. Operators, on the other hand, I think have the challenge of too much data. If you take any of these gentlemen here, they are staring at, if data is gold, a gold mine. However, operators can often suffer from too much data. Is it useful? They often get 50,000 alerts per day. So I think the examples that I've given are examples of taking this whole data concept and overcomplicating it. Google managed to summarize the internet into a single search field. And I think mining can be the same, can be applied to mining. I think IntelliSense.io really aims to do that for mining, to try and take something that is extremely complicated and turn it into something simple to use. So let's get into the product and show you how we use data, create data, and make it simple for everybody. So I've arrived at another solution panel here, identifying the material model for the plant and the grinding application. So I'm now moving into this area of a mine. The material model that we talked about in the previous solution panel continues into the plant, taking a number of different areas and getting more granular at this stage. What I've done here is shown you a set of variables that would be close to impossible to monitor in real time, not only through the inhospitable nature of, for example, inside a SAG mill, but also the flow of material outside of that SAG mill, the residence times inside some of these. And you can see here that I've produced what we call virtual sensors, all in real time for some of these variables that I've just talked about. Cyclone discharge, the feed to the leach, and some of the residence times. So I've created new valuable data for operators and engineers to use. However, also at times, because we do a dynamic mass balance of the entire circuit, we obviously generate the same data as potentially you are monitoring. So in this case, what I'm showing you is the material model output as well as the actual output. And you can see here I've highlighted areas where maybe the instrumentation is off for a short period of time. You can see that the material model or the virtual sensor takes over and fills this data. So this means that you can now continue to use your controls if, for example, they're reliant on a variable, and you can continue to make the same decisions as if all the instrumentations were correctly working. The question that comes to mind, which is, this is all based upon instrumentation data from the laboratory, things like that. How do I ensure that that data is accurate? And so within Brains app, we provide a configurable reconciliation application. So if I take the grinding circuit, which is here, and I look at the information on this asset, and again, I go to the files, which gives me all the information about the grinding circuit, I can see the reconciliation which is being generated automatically. This is simply set up and configured by the user and can be used to identify different reconciliation characteristics. I'm going to quickly show you an ideal reconciliation and then and not ideal reconciliation. So what I'm showing you here is in the first column is a set of assumptions that I know from instrumentations. For example, I know the fresh feed into my SAG, I know the volumes, and I know the densities of my material that I may have sampled at some point. I then give these claimed values a min and a max. So I give it a constraint or a threshold or a confidence interval as to how confident I am of the variable. IntelliSense reconciliation then runs through up to 500,000 simulations until it reaches 20,000 solved solutions until it gives you a set of reconciled values. That is a lot of processing power to achieve this. And you can see in some of the diagrams below, and this one went very well, is that I have solved for these unknown ones, the reconciled values, i.e. this green value. So this value for SAG feed water over the past month of October, I can now see within a few seconds based upon this new approach. Let's have a look at, see what happens if things don't go so well. So in this case, my plant, it may be the next month, for example. I do the same process. I fill in the variables that I know, and I fill in my claims. However, in this case, the reconciler could not come to, even through all of those potential millions of solution finding, could not come to a solution. And you can see here that we're 100% out of the bounds that we set. So what I have here is the warnings of which variables are not featured within my bounds. So if I scroll down, you can see the two here. So through our reconciliation, we've found the whole distribution of the curve of all of our solutions. And we can see that obviously in this case, one of our variables, whether it be an instrument, whether it be a sampling process for these SAG launder slurries, may be completely out of our bounds. And therefore, we may need to go look at that instrument or check our reconciliation. And so now I can generate these every month. On a normal basis, however, reconciliation is often done by an extremely trained metallurgist who uses Excel. I guarantee you that Excel could not produce distributions of up to 20,000 solutions, nor could it take the processing power and speed at which these are done every month. So this is one of our great add-ons, which comes with Brains app out of the box to provide you with value, not only from our applications, but also from our platform. If I go back into the world of grinding, now that I'm confident in my instrumentation and I'm ready to go, I'll continue down and look at the grinding and comminution circuit itself. So once we mine for rock, we need to break it down into smaller particles to get out the valuable mineral. And we use very large drums to do that. These are hugely energy intensive. I think a small percentage of the world's power is used to comminute or reduce the size of rocks. And it is an incredibly energy intensive process. So the better we can make it, the better really for the planet overall. One of the things that's done is we put inside the grinding circuit a set of steel balls. These steel balls we often refer to as a charge, i.e. the percentage of mass inside my SAG mill, which is made up of balls. There's an ideal case for this. There's a number of balls that we need to maximize the particle size distribution coming out of the mill. So we're grinding material down to the perfect size so that we're not over grinding it using too much energy, but we're also not under grinding it and allowing less liberation. So knowing this is hugely valuable in an operational sense in real time. To give context, the only other way to find out this charge is by stopping the mill entirely, stopping throughput and valuable material coming through your SAG mill, and coming out the other end. And so often a set of operators or employees will get into the SAG mill, measure this manually. So if we can stop these shutdowns, we're ensuring that the throughput remains consistent. And less throughputs means more, less stoppages means more throughput. So as a simple example, I've shown you here the different ball charges and their limits. And so if I zoom out a small bit, you can see over time how my ball charge changes within the limits. You can see in maybe these areas where I'm looking at lower ball charges, the add balls alert widget will flash red. We're looking forward to graphite here, where we can actually recommend the tonnage of balls required to add to the mill. What's really interesting is that all of the IntelliSense applications come with financial models built in. So you can see over time here the value that I'm adding to my circuit through in real time with this model. The other area of concern in the area of grinding is the liner, ensuring that the liner capacities are maintained. And so we model this also in real time, converting the percentage wear into useful insights in terms of how many hours it is until you need to shut down your mill. This is all useful information in terms of almost asset predictive maintenance here, as I've almost indirectly highlighted this. The question might be, why are we doing this? Surely you want to optimize a SAG mill using your classic machine learning. I think one of the main reasons we do this is that I think everybody and a number of consulting companies can take a large set of data, put it into an off-the-shelf machine learning model and produce outputs. However, we all know that both the material going through that piece of equipment and the status of the equipment itself is required to get accurate answers in terms of predictions of the future. This is what really makes IntelliSense and Brains App a mining product, is that we ensure that we know the status of each equipment as well, which can be used by our more complicated AI models. So in this case, the model is able to understand the status of the equipment as well as the material. In this case, I'm showing you an overload. An overload event is when the material coming in is too heavy and we cannot process it. What happens is the weight goes up, the power goes up, and eventually the material cannot make it through the SAG mill. So in this case, I'm just showing you a simple example of where the weight has gone up. Our predictions have said that. Our power is going up. And you can see here our overload probability has also gone up. In that case, you can see here the overload alert in red has come on, and it's come on at about 9:15 in this case. These are my control variables that I'm showing you in blue and in green. An operator needs to react to reduce this. However, you can see the reaction in terms of reducing the feed rate, how much material and flow rate, is about half an hour later after the original alert is given. So this will then cause instabilities later on. The final step of this is obviously all of this is enhanced with that material model and virtual sensor outputs. So I'm showing you here a number of different ones. So you can see the residence time increasing, you can see the density increasing. So all of this really just allows an operator to make a better decision. I think one of the topics that we need to bring up is that an operator should not have to make decisions all the time. If decisions have been come to, an operator now and trust them, why not automate those decisions? And so how do we deploy an AI solution, for example, within an existing OT network? This is a hugely challenging task. The computing power required to do the things that I've just shown you is vast. There are security issues around putting new data generating models on a mine site. And there's also the classic one of internet as well. The internet makes all of this possible. However, on a mine site, if the internet drops, which it often does, it's not ideal. So how do we build that robustness into this? So what IntelliSense has done as an industry first, which is deployed our AI models on the OT network on a compact version of Brains App, which we call Brains App Lite. This means that the data, the recommendations that I've just been showing you are all reliably coming in. The data collection as well can be done reliably, and all of the machine learning training and things like that can be sent to the cloud and processed using all of our power that we have. We can then update Brains App Lite to the latest optimizer and allow it to continue to provide recommendations, not only to an interface, but also with existing control systems. That brings me on to the topic of AI and its transparency. I'm showing you here a set of real life training events that we've done across all of the geographies that we cover: Kazakhstan, Chile, Australia. One topic that comes up always is the underlying expert system. One thing about those is that existing expert systems are not transparent. They do what they need to do based upon a set of rules which have been applied logically. And I believe that they're only getting better at being more reactive or getting and hitting a number that they're trying to achieve but may not be possible. They're very intrusive and they make changes all the time. They're not retrospective. And as a result, the more complex an expert system, the less likely it is to be used. IntelliSense would like to help the mining industry with a new proactive approach to optimization above a control system. If I take the simple example of Google Maps, we don't put into a GPS. If I put into that, I would like to get to my destination in 10 minutes. That's not how it works. We define our best to Google Maps. We say, I would like to get from A to B in the shortest time possible. That's me defining the best. It's in mining, for example, it shouldn't be, I would like to run at throughput X. It should be, what is the best throughput I can achieve right now? And this new approach involves training. It involves a new way of thinking. But what IntelliSense has done is created an out-of-the-box value driver. In the case of a GPS, the out-of-the-box value driver is get me there in the quickest time possible, not get me there in the most efficient time or the quickest. And so I want to show you how Brains App has done that. I've now arrived on the optimization admin screen. The optimization admin screen contains all of our optimizer types. We have different types for different processes and our different apps. We have thickening, grinding, flotation. Within thickening, for example, I now need to set up different optimizers for different setups. So I have ones for the different types of thickeners. So we have concentrate thickeners, high density thickeners, and paste thickeners. If I pick the high density thickener, which is the most common thickener, what I've done here is I've set up a set of rewards that I'd like the thickener to achieve. What is the best that this thickener can do? I'd like it to maintain a mass balance of 0. I'd like to ensure that the flocculant is minimized. I don't give it a flocculant set point. I'm trying to ask it to minimize things and maximize things and to make sure that it stays within constraints. Once I've done that, in reality, we all know that different things happen. And so what I now can do is set up different scenarios. So one optimizer might work in one case, but not in another. And so the dynamic nature of mining is now here. So for example, if my plant is shut down, I may have a different way of running my, to achieving my best versus if I have low throughput, or for example, the material characteristics change, which is very common. So for example, if I have a shutdown, I'd set up my optimizer configuration for a particular scenario. So I'm driving towards the best I can do in a particular scenario. The best may not be a number, but let's show and see how that's done within the app. To explain a thickener very briefly, it is a liquid solid separation process where a slurry comes in, which is a mix of solids and liquids, and we need to recover the water. I mean, if we take chili as an example, water is very valuable. We need to ensure that it is recovered and used again. And so to do so, we need to ensure that the underflow percent solids that we achieve is as high as possible. What I'm introducing you here to is Brains VOS, our virtual operations simulator. We often call this inside at IntelliSense our little time machine. It's a historian of the future and is our powerful what-if tools. This can be run non-intrusively, and it can be used to simulate different control regimes and to see what our optimizer is thinking. It's an extremely powerful tool in the battle for AI transparency. The first thing I'd like to highlight is an example of it being used. First thing I've done is I've gotten all of my brand new feed variables from my material model and the predicted state of those. So I now know my feed flow rate now, and I know my feed flow rate at T plus 55 minutes into the future. So I can make predictions. I know what's coming. I know I can now predict what to do next. At present, my data is really good. I don't have any kind of quality issues with my data. So let's get started and try and achieve the highest value that we set in our rewards. In this case, I'd like to maximize my underflow percent solids, i.e. this blue line, but making sure that it stays within those limits that I've set there. My bed pressure, again, I'd like to make sure it stays within the limits. I'd like to keep my mass at 0, perfect balance between input output. To maximize my flocculant's an expensive chemical formula, and so we want to ensure that we don't put too much of that in. And then we want to ensure that our rake height and torque are maintained. What I've shown you in the majority of these cases are the underflow percent solids as it is today and a predicted state. So what will my underflow percent solids be in 55 minutes from now? Which is again an incredibly powerful tool to start us off. So now that I've broken one of my constraints, I need to make a change. So I have two control variables in the thickener. I have the flow of the flocculant and the flow of the output stream. And so again, in the same theme, I'm showing you here the actual flow rate and what the optimizer would have done in this situation. But how did it come to this conclusion? How did it know to increase the flocculant flow rate and underflow? Well, let's try and get inside the mind of our optimizer. So we take our rewards here. What I've set up is a visual representation of all of those rewards. And you can see during the times when I've broke the limit, the majority of my rewards or the concentration is making sure that constraint, 63% of my focus is on making sure that that constraint is not broken. 24% on that bed pressure constraint, and the rest take lower preferences. So that's how I came to that conclusion. And the underflow percent solids and the bed pressure, as a result, I can show the uncertainty of those. So for example, if the model has not seen this set of data before, and it's not sure what to do next, the uncertainty can be too high. And so the operator can see, hey, we're not really too sure what to do right now. I'm unsure of what to do. We want a humble model. We like humble people. We like humble models. And so if the uncertainty gets too high, We obviously would not give a recommendation in that case. But what's really interesting is that this is almost as if a human brain thinking. And you could argue that, well, when I break my constraints, I probably don't need an AI model to tell me what to do next. However, let's take a quick look at maybe a timestamp when things were less obvious. So if I scroll back a few hours before, you can see here I'm plowing along as best as I can. Nothing really to report here. Well below my limits, trying to maximize my underflow percent solids, keeping my balance. Everything's going great. And so this is really where the rewards kick in. So this is where the human brain would have to take capacity and go, how can I balance everything that's going on here? So for example, the numbers that I'm providing you, 47% of those will make sure that the flocculant dose is minimized. 40% will ensure that that underflow percent is maximized, and a small portion will ensure that the mass balance is maintained. So this is that transparency that we've added to our products. But all of that is very useful for my operator, but what does it mean to my bottom line? Optimizers are here to ensure that I achieve the highest value. And so how really listening to that optimizer, how do I know that I'm achieving the highest value? And so, as I said, all of our applications come with a financial model. And so what I'm showing you here is the actual and optimized cost of my flocculant in terms of dollars per hour, and the revenue I'm achieving based upon the actual and optimized states. I can then compare those two and accumulate them over time. So I'm taking a period here of a few hours, and I can see my opportunity loss. So in this case, I can look back in time. I can be retrospective and say, I should have done this. If I had done that, I would be sitting here with $116,000 more. And so bringing this back and ensuring that the opportunity lost is shown really adds to that transparency as well. What I've just shown you is complicated stuff. I would agree that most operators, engineers may struggle with some of these concepts, but IntelliSense is always here to help. And I would like to now introduce, in fact, the best way of helping everybody, which is through our little friend, the Brains Genius. So Brains Genius wanted to come and say hello to everybody to show you all what we can do to help, because this is the final step. So Brains Genius is here at all times. He can bring you not only to the IntelliSense Academy, which has a number of courses outlined for all users, ranging from small periods, and certification is provided once complete. Now that Brains Genius is gone and he successfully completed his certification at IntelliSense, let's get back to the mine site and do some practical help here. So here he is inside Brains app guiding you. He's here to show you handy tips like this small drop down that reveals the icon in terms of the logic and the transparency behind what we've been given. If you're not happy with Brains app, we have a whole help center full of hints and tips. So I'll just quickly go to that now. And what is really exciting is that I can show you all of the different articles we have on everything to do with AI and mining. But also what's really exciting, I think, is that we have the Fluorite 2020 release note here ready for you all. And all of the links, everything that I've talked about can be found here, discussing grinding, even some of the work on flotation that we've done. So please feel free to come and have a look at our release note as well. If not, we also have a very friendly support chatbot as well. But Brains app is going to say goodbye for now. Thanks a million. He's really looking forward to graphite as well. I'm sure he'll have some kind of fantastic new onboarding approach to see from him. So just to make everybody clear on that, while I'm in the product, I can click down here, I have a friendly chatbot in which I can start a conversation with IntelliSense, who will respond to me in about 30 minutes. Back to what we were talking about earlier with Brains Genius. So with Brains Genius, we were talking about the operator screen. This operator screen is designed for our operators, and it's like their small GPS. So what I'm showing you here is a quantitative way of showing outputs. This is showing you not only the change in my control variable that I would need to do into the future, this hashed area being the future, but also the effect it has and the uncertainty bands that it will happen. So it's instead of saying, if you generally turn this up, this goes down, we're now going into the world of, if you turn this up by 10, you'll see this result. And as I said, that transparency that Brains Genius showed me is all here. You can see all the errors as to why we potentially would not provide you with a recommendation. Once the operator is trusted and happy with all of these, we can obviously deploy these through Brains App Lite on your OT network so that these recommendations are not provided to a human. The final piece that I'd like to talk about is a quick summary of what we've seen today. I've really talked about an industry that for me was challenging and hard. Mining is hard. It's not only an environment which is hard, but also it brings up so many challenges. And for me, the main focus of what makes mining hard, and therefore AI and what Brains App is trying to do hard, is the variability. So we've talked about the material movement, linking upstream to downstream, bringing more transparency, ensuring we're all speaking the same language, and taking that variability out of the equation. Data in mining can be relatively abundant, but using it, generating the correct data, generating more data and quality and in an automatic fashion is also hard. But IntelliSense ensures that every single one of their optimization applications comes with the highest transparency in terms of data quality and understanding what data is being used for each model. The third point is obviously the organizational change. And we've just shown you there how IntelliSense is trying to help, how IntelliSense is trying to make the next step for so many companies an easy transition. And from experience, people get really excited about this on mine sites. And it is a real great satisfaction to go to a mine site and show this to people and show the value and the new way of thinking. And I think the people upping their own careers is a fantastic sight and one of the best rewards that I've personally got from the transition with IntelliSense and coming to all the mine sites and showing them AI. And I'm really excited that we are maturing and that everybody within this space can start to learn how to start their journey. And in fact, IntelliSense has made a contribution this release to the industry to try and help. We've made from today available to everybody within mining our digitalization maturity assessment, which gives you that conversation starter and the first point of call in terms of your journey into mining and AI and digitalization. Is to find out where you are and where you need to go. So if I quickly visit digitalization, this is our digitalization maturity assessment, open to everybody on this call and everybody within mining so that we can take our assessment here. It's a 5-step process which will provide you with recommendations as to the next steps to take. And so I really encourage everybody here to go and assess their own mine or their company, and let's try and make this change together. Now we're going to go into a Q&A session with myself and Sandro, our CTO. So I'm really looking forward to hearing what you guys thought of what I've shown you. So thanks a million, and go ahead and ask. Really excited to answer.